Good morning to everyone. I am P.M.Arthi, Assistant Professor in the Department of Artificial Intelligence and Data Science in Tech Multitech, Dr. Rangaraj and Dr. Sakuntala Engineering College. Here we are going to see about the topic three-dimensional object representation in the course of computer graphics and multimedia. 3D object represents refer to different way for storing, visualizing and manipulating 3D object in digital space. Their representations are crucial in computer graphics, 3D modeling, visual and realities, computer vision. Some common types of 3D object representation. 3D object representation is divided into two categories. First one, boundary representation. It describes 3D object as set of surface that separate the object interior from the environment. Is referred to. It also represents the method for defining 3D object by describing their boundary surface rather than volume. It's widely used CAD, solid model and computer geometrics. Next one is space partitioning representation. It is used to describe inner priorities by partitioning the partial range contain the object into the set of small inner overlapping continuous soliding. It a representation divided in three 3D space into smaller structural region to efficient stores, process and render object there. Their representations are widely used in computer graphics, computational geometrics, game engineering, and robotics for tasks like detection, ray tracking, partial indexing. Next one is the polygon surface, the most commonly used representation for 3D is graphical object. It is a set of surface. It is a polygon that encloses the object interior. The polygon surface represents is one of the most common way for method 3D object. It optimizes the surface using the merge of collected polygons. This method is widely used in CAD, gaming, animation, and simulation. Set of polygons are stored for object description. This, this simplifies and speed up the surface rendering and display the object since all surface can be described with inner equalities. The polygon surface is divided into three categories: polygon table, plane equation and polygon mesh. Polygon table. Polygon table rough is divided into three categories: vertical table, edge table and polygon surface. The above polygon surface we represent the vertical table in V1, V2, V3, V4, V5 and edge table in E1, E2, E3, E4, E5 and E6 and the polygon surface S1 and S2. Here the polygon table divided into three categories: vertex table, edge table and surface table. Polygon surface table. Vertex table. Vertex table contains vertices and its coordinate points. Vertex V1 contains x1, y1, z1. Vertex 2 contains x2, y2, z2. V3 contains x3, y3, z3. V4 contains x4, y4, z4. So and V5 contains x5, y5, z5. Then edge table. The edge table is used to store the edge information of the polygon. Here it contains edge and its connected vertices. Edge 1 contains vertex V1 and V2. Edge 2 contains vertex V2 and V3. Edge 3 contains vertex V3 and V1. Edge V4, edge 4 contains V3 and V4. Edge 5 contains V4 and V5. Edge 6 contains vertex 5 and vertex 1. The last one is polygon surface table. The polygon surface table stores the number of surfaces present in the polygon. In the polygon surface, the polygon surface table contains two surfaces S1 and S2. S1 surface connected through edge 1, edge 2 and edge 3. Surface 2 contains connected with edge 3, edge 4, edge 5 and edge 6. The plane equation. The equation for the plane surface can be expressed in Ax plus By plus Cz plus D equal to 0. The plane equation in 3D describes the flat infinite surface using the mathematical formula which widely used in computer graphics, where x, y, z is any point on the plane and the coefficient of a, b, c and d are constant, describing the partial properties of the plane. We can obtain the values of a, b, c and d by solving a set of three plane equations using coordinates value for three non-collinear points in the plane. Let us assume that three vertices of the plane are Vx, x1, y1, z1 and x2, y2, z2, x3, y3, z3. The equation for the plane surface can be expressed as ax plus by plus cz plus d equal to 0. We can obtain the value of a, b, c and d by solving a set of three plane equation. A plane in 3D is defined by ax plus by plus cz plus d equal to 0. A, B, C are components of plane normal vector n equal to a, b, c. D is the constant that determines the plane's position. Let us assume that three vertices of the plane x1, y1, z1, x2, y2, z2 and x3, y3, z3. Let us solve the following simulation equation for range of a by d, d by d and c by d. You get the value of, by dividing d in the all the equation, we get a by d x1, b by d y1 and c by d z1 equal to -1. And a by d x2 plus a by d y2 plus c by d z2 equal to -1. A by d x3 plus a by d y3 plus c by d z3 -1. To obtain the above equation, the determined matrices are A equal to 1, y1 z1 1, y2 z2 1, y3 z3, B equal to x1 1, z1, x2 1, z2, x3 1, z3, and C equal to x1 y1 1, x2 y2 1, z2 y2 z3 x3 y3 1. Then D equal to minus of x1 y1 z1, x2 y2 z2, x3 y3 z3 for any point x, y, z with the parameters a, b, c and d. We can say that ax plus by plus cz plus d not equal to 0 means the point is not on the plane. It's not on the plane. Next, ax plus by plus cz plus d less than 0 means the point is inside the surface. It's present in the inside the surface. The point present in the inside surface. Ax plus by plus cz plus d Greater than 0 means the point present in outside a surface. Next one is polygon mesh. The 3D surface, the solid can be up. Polygon mesh. 3D surfaces and a solid can be approximated by a set of polygonal and line elements such as surfaces are called polygon meshes. In polygon mesh, each edge are shared by at most three polygons. The set of polygons are faced together from the skin of object. The polygon mesh is collected of polygons used to represent 3D surfaces. It defines the shape and the structure of 3D object using interconnected vertices, edges and faces. The topological elements are half edges, store organization, edges, loops, closed sequence of edge defining boundaries, shells, group of connected face forming a closed volumes. Next one is the type of polygon mesh, triangle strip. The triangle strip made entirely of triangles. It is fast rendering used in gaming, VR and real-time graphics. Next one, quadratical mesh made up of quadratical faces, ear- earlier for animation and other computer graphical process. Next, used in character modeling and etc. Advantages of polygon surface: it can be used to model almost any object. They are easy to represent as collection of vertices. They are easy to transfer. They are easy to draw on computer screen. Disadvantages are curved surface can only be approximately dis- described. It is difficult to simulate some type of objects like hair or liquid. Curved line and surface. The curved lines are essential in to create smooth organic space. Unlike polygon meshes, curved representation used mathematical function for modeling. Curved curves are used to define smooth path or outlines. Most common types in the curved lines are quadratic surface, planes, double planes, intersection planes, parabolic cylinder, elliptical cylinder, parabolic cylinder to hyperbolic cylinder, elliptical cylinder to elliptical parabolas, elliptical parabolas to ellipsoids and cones, hyperboloids, hyperbolic paraboloids, hyperboloid. Think about how we draw a curve. If you are sticking the hand, you are made a smooth stroke, adjust the pressure and the direction naturally, but the computer graphics, we need to weigh the mathematically define the smoothness that were curved like Bezier curve, spine curve, etc. The Bezier curve, for example, like pulling on the electric stick attached to the few points. When the more point you add in, the more control you have hand over the shape. That's why it's possible in animation and UI designs. It is very easy to use. Now you take the concept of extend it into 3D. You get curved surface image on a piece of fabric stick over multiple control points. That's essential how Bezier curve surface work. They are used to design things like car bodies, aircraft wings, and other models in movies and games because they allow for smooth following shapes. On the other hand, real-time applications like video games often the approximate curves in the polygon because they are easier for computers to process. That's why highly detailed models use technology like subdivision surfaces take a root of polygon surface and smoothing it out dynamically. At the end of the day, the curve lines and the surface are above prescribed and efficient. If you need smooth, you have to go Bezier surface, the Bezier curve on the surface. Imagine you are drawing the smooth curve on the paper, but instead of freehand, you are place a few dots and let the curve naturally follow the instance. That exactly how Bezier curve works. It does not pass through all the points the point but the point put in the content direction, shaping and smoothing. The Bezier curve is partially a kind of spline generated from the set of control points by forming in a set of polymetric function described by the French engineering Bezier. This function are computed from the orientated or control point. This curve can be generated under the control of other points tagged by using control points are used to generate curves. It is approximate a spline curve. A Bezier curve is defined by defining polygon. It has no prior properties that made them highly useful and convenient for curve and surface design. Now the simplest Bezier curve is just a straight line between 2 points. At third point, and you get the quadratic curve that at the third point you have get the quadratic curve that bend towards the middle point. And the fourth point you get the cubic Bezier curve, which is the most commonly used in animation, UI design, and vertex games. It gives you enough flexible to create smooth transmission without getting too complex. Let us see the 3D instance for just controlling the line, image, or sticking a piece of fabric over the multiple control points. That what the Bezier surface does. It efficient the idea of Bezier curve into two dimension, creating smooth flowing surface instead of just curved line. The surface are super used, useful to 3D model, CAD and animation because they allow designers to create organic shapes like a car body, animal characters, or craft wings without replay on rare polygon. But a single laser surface can get tricky to manage with a lot of points. More advanced versions are often used to professional design surface. Different types of curves are simple, quadratic, and cubic. The simple Bezier curve is straight line from the point. It can contain 2 points. Quadratic Bezier curve is determine the three control point. It bends the quadratic curve. The cubical curves determine the four control points. Here the simple curve. We place point P0 and P1, connect it and form a straight line. And the quadratic curve, it have three control points P1, P2 and P0 to connect them. Quadratic curve, the straight line bend in the middle point. Next one, cubic curve. The cubic curve have four control points P0, P1, P2 and P3. It connect P0 and P3 and bend depend on the P1 and P2. Properties of Bezier curve. They generally follow a shape of control polygons which contains of segment joining the control points. They allow the pass through first and last controls. They are contain a convex hull of their defined control point. The degree of polymetric polygon defining the curve segment is one less than number of defining polygon point. Therefore, for four control points, the degree of polygon is 3 polygon cubic. The control point increases, the polygon values is also increases. If you have four control points, it give three polygon value is 3. If you have two control points, the polygon value is 1. The Bezier curve generally follow the shape and defining the polygon. Next one is B-spline curve. B-spline curve is also like a Bezier curve. In the Bezier curve, any points changes, the entire curve will be changed. Therefore, it called as global control. B-spline curve, if any point change, only change that part of the curve only. Don't does not affect other part of the curve. So it is called as local control. Think about how to draw a curve. If you are sticking on the hand to the polygon surface, the Bezier curve like pulling on string with a few fixed points get you a smooth curve, but every point affect the entire shape. Now, what if you want more control without affecting the whole curve when you adjust one point? That is the B-spline curve. A B-spline curve is just more flexible version of Bezier curve. Instead of defining the whole curve with a single set of points, it divided the curve into sections that let you edit on part without mess up the rest. This make B-spline is great for complex design, CAD models and animation because you can fine tune curves smoothly. Now imagine apply this concept to the surface. A B-spline surface is like a smooth sheet over the grid of the control point, but instead of being influenced by all points equally, only local sections are affected when you move the point. That's why B-spline surfaces are widely used in 3D modeling, industrial design and animation. They give designs precise control while keeping surface smooth. B-spline give more local control than Bezier curve. The properties of B-spline curve: the sum of the B-spline basic function for any parameter values 1. Each basic function is possible or 0 for all parametric value. Each basic function has preciously one maximum value except for k equal to 1. The maximum order of curve is equal to the number of vertices to define the polygon. The degree of P-spline polygon is dependent on the number of vertices of defining polygon. P-spline allows a local control over the curved surface because each vertex affects the shape of the curve only over the range of parameter values which where is associated basic function is non-zero. The curve habit